Okay, so this is a bit of a tricky integral that you have to do. Now, let's just first set it up, and then, well, actually, first let's talk about the tricky things. So a couple of them are, at some point we're going to have, I think this is the expression, and basically we're going to minus 1 plus 1 so that we can get, u squared minus 1 divided by u squared minus 1 plus 1 divided by u squared minus 1. We're essentially doing the division, and so we get 1 plus 1 over u squared minus 1. And we're going to integrate this, so integrating 1 is easy. That's just going to be u. Integrating this, we don't quite know how to do, but if it were something like 1 over u minus 1, this we would know how to do. The answer is log u minus 1. So whenever we have sort of 1 over something that's linear, it's very easy. The answer is log. So what we're going to do is use partial fractions, which is a technique that takes something in the denominator, and if it factors, which this is a difference of squares. A difference of squares always factors, and factoring reveals information when you can do it. And so let's do it. This becomes a u minus 1, u plus 1. And so what we have is 1 over u minus 1, u plus 1. And the question is, this is partial fractions. Can we write it like this? If we can figure out what a should be and what b should be so that this is a true equation, then we can integrate this original thing, which we don't know how to integrate, by just doing this integral and that integral, which will just be a log u minus 1 and plus b log u plus 1. So that's the whole point, because we can integrate if there's just a linear factor in the denominator. That's it. Okay, so now to find a and b, we just clear denominators. Clear denominators. So what do we get? We get 1 equals... Now, this whole thing is going to multiply both of them, and the u minus 1 will cancel, so we'll get a times u plus 1 plus b times u minus 1, because here the plus 1's canceled. I cleared denominators. Pause the video if you want to just check this. Now, what I do is I have 1. The 1 is secretly 1 plus 0u. And over here I get au plus a plus bu minus b, which is a plus b plus u times a minus b. Wait. I flipped that around. I'm just collecting sort of in terms of u, the 0th power of u and the 1st power of u. I get a minus b here and a plus b there. I think that's right. So what I see here is that this equal sign is really two equal signs, because a polynomial in u equals a polynomial in u can only be equal if this coefficient equals 1 and this coefficient equals 0. In other words, 1 equals a minus b, 0 equals a plus b. And I can solve this system of two equations and two unknowns. The first one says a equals b. No, it doesn't. The second one says a equals minus b. And then I get 1 equals minus 2b, so minus a half equals b, so then plus a half equals a. And I just solved it, but you solve your own way. Which means my original decomposition, if you will, of this factor up here means that all this becomes 1 plus, now what's a? 1/2. 1/2 over u minus 1 plus b is minus a half over u plus 1. Okay, and because we're going to integrate this, now it's easy. We can do it. The integral of all this is going to be u plus a half log u minus 1 plus minus a half log u plus 1. Okay. So now that I've sort of done the hard part, let's actually see how that arises in the problem. So here's the curve. We want to get the length. The length is the integral of the speed. Okay, so first we need the velocity, which is 1 comma 1 over t. So the speed is the length of the velocity vector. So it's the square root of 1 squared plus 1 over t squared. And so we need to integrate that, let's say, from t equals 1 to 2 for part A. 1 plus 1 over t squared dt. And now a 1 over t squared is sort of annoying, so we can factor it out. 1 over t squared plus 1. So that's actually a little confusing. So take a moment and pause the video and see how I did that. And the reason is t is positive, so now I can just pull out a square root of t. Usually square root of t squared would be the absolute value of t, but if t is always positive between 1 and 2, then it's just equal to t, and it's in the denominator. So this becomes 1 over t square root of 1 plus t squared. I don't know why I switched the order. Somehow I just like it this order better. dt, integral. Okay, and now it's clear why they say make the substitution u squared equals 1 plus t squared, because this will then become square root of u squared, which will be u, hopefully, if u is positive. And so what do we get? So, well, if this is our substitution, then 2 du du equals 0 plus 2t dt. And cancel the 2's. U du equals t dt. So all I have is a dt. It would be nice if I had a t dt. So I'll just multiply by t and then divide by t. So in all, that gives me a t dt, which will become u du. And then a 1 over t times 1 over t is 1 over t squared. So then, what's t squared? T squared is u squared minus 1. And I have 1 over t squared. So 1 over t squared is 1 over u squared minus 1. This becomes a square root of u squared, the whole thing. And these two become 1 over u squared minus 1. And all in all, my integral becomes u du times another u is going to be u squared du over u squared minus 1. And now, if t was going from 1 to 2, then u is going from something to something. If t is 1, I get u squared equals, let's see, so u equals root 2 up to u equals, okay, 2, 4, 5, maybe that. How about that? And let's do it positively. So let's take the sort of the positive branch of u's, so that this square root of u squared is actually a u times u, which is u. Anyway, hopefully this makes sense. Square root of 2 to square root of 5. And now we have an integral that we can do by partial fractions, because this denominator was sort of split up. And we're exactly at the point right here where we have u squared over u squared minus 1. We do plus minus the same thing. It's essentially doing this division for us. If you wanted, you could actually just do the division. So this is sort of a sneaky way to do the division. But a more straightforward way would be, oops, that's a square root sign. I want a division sign. So how many times does u squared go into u squared? Once. Minus u squared. 0 minus 1. And so now, how many times does u squared go into minus? Oh, I am doing, so I'm doing the wrong division. So u squared divided by u squared minus 1. Okay, so how many times does u squared go into u squared? Once. Then I get a whole u squared minus 1, which I will subtract. This is how you do division. The u squareds cancel, then I get a plus 1. And that's my remainder, because u squared minus 1 doesn't go into the plus 1 anymore. So what do I get? I get u squared minus 1 goes in once to u squared, plus a remainder, and the remainder is 1 over this. U squared minus 1. And anyway, you can check by multiplying this denominator through here, and you get the right thing. Okay. I think. Right. Yeah. Anyway, this is confusing. So take your time and make sure you see the several tricky things that are happening here. One of them is partial fractions. This is incredibly useful. You might think it's not, but it just comes up in so many different situations. So it's good to know it. And then what's the other tricky thing? Well, the whole idea is so that we can integrate. So we can get things that become log when we integrate. And yeah, then you should be able to do this. So what is it? 1 plus 1/2. Let's copy that. Yeah. And so we get u plus 1/2 log u minus 1 minus 1/2 log u plus 1, and evaluate that from root 5 to root 2, and you should subtract and get the right answer. So let's see if I put root 5s in there, and then some root 2s, and then sort of the log you can divide. Remember there's rules for log, so this looks right, because the log of a times b is the log of a plus the log of b. And so if you have a log of a minus a log of b, you can turn it into a log of a over b, and all these sort of rules which follow from the definition of log. Okay. So good. If you need to brush up on log, I would suggest Short Calculus by Lang, Chapter 8. This is a tough, tricky problem, but the tricky things are worth paying attention to. They're actually worth your time. They're not there just for no reason. They're there because the same tricks keep coming up in math. Okay. Bye-bye.